Hey! This app shows you how you can easily extend your CM system with artificial intelligence. Instead of building a whole CM system, the app mimics the first day in the life of a new police officer. Now imagine we are this police officer, and our job is to place 15 police cars in the city of Chicago. But since it's our first day, we first need to get the feeling for the data. So we open the first dashboard of our app. This dashboard shows us the historical data of January 2018. And we see that we have one hotspot here, but the rest is somehow varying. We also see that the number of crimes per square changes by time. Our job is now to place 15 police cars in Chicago to prevent as many crimes as possible. Since we don't have any experience with the distribution of the crime hotspots, we first rely on the data of yesterday. So we place the police cars according to the hotspots of the day before. After we set the cars, we submit the plan and our colleagues are driving to the squares. At the end of the day, we return to our dashboard and evaluate how good we did our job. For the sake of simplicity, we assume that the police car prevents all the crimes happened in its square. And well, we see we did a good job. Thanks to us, 350 crimes have been prevented today. Well, so far we did everything manually, but let's see how machine learning can help us here. In Splunk we can use the machine learning toolkit. We here fit a linear regression on the number of crimes per square on the data of 2001 to 2017. As features we use the number of crimes 1, 2 and 3 days before, we use the moving average of a week, 2 weeks and the month, and of course in which square we measured. As I was talking, the model was trained, and now we can check how this model can help us. So again we have the same situation here. We have to plan where the 15 cars should go. But this time we won't make the plan ourselves, but let the model do the work. So now we simply click on compute and the model is doing its job. It's predicting the number of crimes in every square and sending the cars to the highest predictions. And again, we evaluate how good the job was done, and we see now we prevented 387 crimes. Now we know that our model works for this particular day, but let's see how it performs for other days. As said, we trained the model on data from 2001 to 2017. And now we're going to evaluate it on every day of 2018. We compare our model to the yesterday strategy. In the yesterday strategy, we sent the cars to the 15 hotspots of the day before. We also compare it to the number of maximum preventable crimes. So if we always would send the police cars to the optimal squares, this would be the number of crimes that we could have prevented. And we nicely see in that graph that our model is always between the yesterday strategy and the maximum number of crimes. In the lower graph, we see the average number of prevented crimes per day. And also here we see that our model is perfectly between our baseline, the yesterday strategy, and the maximum number of preventable crimes. So linear regression is a pretty simple model and also our features are pretty basic. If you like, feel free to play around, use a more sophisticated model, create more features, or do whatever you like. Have fun with the app!